right, hello everyone. Thanks for joining me. As you know, I'm Florian. I would like to tell a little bit of things about the Fable compiler. I'm assuming everyone kind of knows Fable by now, and will have. I hope you leave this room with a broader sense of what it is. So, on our agenda, we're gonna have like the deep dive. How do we really go from F# to JavaScript? What really happens? Why we have Fable clients, and then think about what could be next for Fable. This talk is for existing Fable users. I've sort of assumed that everyone in the room compiled Fable at least once, so maybe raise your hand if you never compiled any F# code with Fable. But you're really welcome as well. We're gonna get you through it. Don't worry. You'll end up with a deeper understanding. And there's also like a bit of a B-plot in this talk. It's a hero's journey where I myself consider myself to be the protagonist in all of this. In February, March, I've sort of added something to the Fable compiler. I had a lot of help, and it's not much, but it's kind of cool. It was a bit of a journey how to discover how to contribute to a more complicated project as Fable itself. We're going to have a lot of demos, so not that much slides, and we're going to talk about F# scripts. Who has never used an F# script before? Very good. That's very good. Cool. What is Fable? When I think of Fable, I think of two components. On one hand, you have a demon, which is Liam Neeson in this case, and there's the Tower of Babel. If anyone gets the reference, really come and talk afterwards. This is like really hard to grasp. But Liam Neeson is doing his thing. He's an F# demon that runs in the background, and he sort of takes the incoming F# code, will do a lot of transformations, and then pass it on to Babel. We have the Tower of Babel, which is the existing JavaScript tooling to compile ES6 code to whatever it should compile. There's like a lot of configuring options, and those two kind of really fit together. And let's talk about that first. So there's a bit of a pipeline to all of it. We start with F# code. It is getting processed by the F# compiler service. Then suddenly we get types AST. AST stands for Abstract Syntax Tree. We suddenly have then Fable AST, go to Babel AST, and go to JS. So it's a lot of transforming this to the next, and it sort of starts with the FSC. FSC, the F# compiler service, and my own view, it's kind of the F# compiler, but you can use little bits and pieces of it. You don't need to give an F# project and it compiles completely to a binary. You can use different phases of the compiler. There's the lexical phase, there's the tokenization, you can get to untyped AST and typed AST. And the community kind of took a fork of .NET F#, the thing Microsoft maintains. And from time to time, they publish bits and pieces on NuGet that existing tooling can use afterwards. So I'm fairly sure that Chris will explain this a lot better. But that's kind of what it is. You can use whatever the F# compiler has, and it gets into, and the community started using it. And what I would like to show you now is some typed AST. I'm going to open the tool. It's called AST Viewer. It's written in Fable, actually. We have some bits and pieces of F# code, and I'm going to reset the view. Apologies. You're just going to sort of have to believe it. We're going to let me just like reload the entire thing. We're going to see what does the typed AST of this look like. This is something Jindrich made, and the cool thing is it runs on an Azure function. We send our F# code as a string. The Azure function uses the F# compiler service, which is the NuGet package, and then it gives us back some sort of tree kind of module. If we look at it in the raw version, sort of readable. I'm just gonna highlight things. We have like two LED bindings here, and we seem to have two of these member or function values. That's the typed AST that comes out of it, and that's kind of the starting point that Fable is using to get to the rest of it. So we sort of have this tree form. I can also see it in the JSON viewer. This is a really helpful tool for debugging these kinds of things. And what this does, it's our starting point to go to fable-AST. Fable-AST is also an abstract syntax tree, and it's something. The fable-AST is an intermediate format Alfonso came up with because going directly from the F# AST to JavaScript was kind of tricky, and it was it was hard to do the whole interrupt story and to replace everything with a mid, and that's why there's an additional AST layer to finally get to fable-AST, which just looks like a piece of JSON, and it's going to contain everything that we actually need to go to the JS code. And we can just use the existing Babel toolchain. So that were some slides, and now I would like to show you a demo. If you ever started from scratch with Fable, you had to do a lot of things, and we're going to do the minimal compilation of all of it. It's sort of the bare bone Fable example. I made a couple of demos. The first one where we're just going to compile ourselves. If we look at the package JSON, we use Fable compiler and Babel core and nothing more. Okay. Yeah. Thanks, everyone. So we only have this, and usually in your own projects you have like fable-loader and fable-splitter or any other sort of clients to do it. So let's see how we can use just the bare bone building blocks to compile it. I have an index.js file, which I'm just going to run with nodes afterwards, and we're requiring the Fable compiler, the default start function, and the transform AST from Babel core. What we're going to do here on line 13, we're going to start our own daemon, and that's the Liam Neeson part. And once that daemon runs, it's in another process. It's sort of a socket server. We can send messages to it. If we go Fable compiler send, we give it a sort of a payload. Then we say we're going to give the app.fx. Let me just quickly show you. Nothing fancy. It's the example we had. We have just one lep binding here, and we have a function over here. So we can sort of expect what the outcome in JS will be. And if we go back, we send it. We get a promise back. And once that promise resolves, we'll get the fable-AST over here. We're just going to close the compiler, as for demo's sake, and then we're just using Babel to transform it and writing it out to a file. If I go to this demo, just go node index. Should go to the right demo, of course. It is running. It's starting our Fable daemon, the Fable compiler. It is taking a while. It's slowly getting me nervous. It parses our app.fx files. So that was the little thing I talked about, the hero's journey. It's now possible again to compile script files. It's just a little tweak I sort of added, and we'll see how that turned out. So basically, when we sent our message, we got a result back. This is the fable-AST I talked about. And that piece of JSON then is transformed to 2 pieces of JavaScript, which we wrote down, and that's kind of it. In the next demo, I'm going to do sort of the same thing, but we're going to hook into an existing Fable daemon. We're not going to start it ourselves. So what I have here, I'm requiring some node dependencies, and I'm going to, connect to a Fable daemon that's running on port 2000. We're actually using another sort of a send message just to connect with a socket to the running Fable instance. We're not starting it ourselves. And the cool thing is that we'll be able to debug the compiler this way. So we're actually going to start the Fable daemon in another project, and we're going to say, run this node file in another process. The daemon is already starting, and both will connect to each other. If I go to my other project, this is just a clone of the Fable repository. There's lots of stuff in here. What we're actually going to start here is Fable CLI. That's kind of the entry point of Fable. You can see if you start Fable CLI, there's a main file, and the main method is what's going to be called. over here. So let me just first show you the configuration. I am going to start the Fable CLI DLL project. That's just like your .NET run kind of thing here. Then I'm giving it some arguments. I'm saying node run debug.js. That's just to have the link to the other file. And I explicitly say it should be on port 2000. And the working directory is the little example I have, and that will start everything. So let me debug my little configuration. The first thing we see in the entry point, it matches our node run. So in this case, we're going to start the server with another process, being node that's going to be run. We are starting an agent to receive the messages. In this case, it's actually a mailbox processor that's is constantly looping, waiting for new messages to come in. And the first thing we'll see once we get the message, it has the arguments we passed in, and it's going to create a sort of a project. It's going to create an F# project with the actual compiler. And if it already, it's trying to reuse existing projects, that's how the incremental compilation sort of works. It just updates the existing thing. But in this case, there's not a project yet, so we're going to create one. And here's something familiar from maybe some people. We're going to have like the cracked project in there, which in the long-term short, it's going to match to the F# scripts, and it's going to try and get the project options. It now came into this method, and we're actually using F# checker. So this is the stuff I mentioned from the F# compiler service. We're going to have some DLL, some Fable packages. We're going to construct all the stuff we need. Going forward, we're making that project. So it ends up being a bit of a mix between the actual F# project and the Fable project. So Fable needs like a bit more. In actuality, the interactive checker will check our incoming F# scripts or our project, and it will create the AST. Moving on with the parse and check, that's actually what will create the AST, and then we just all hook it up, set it up to the compiler, so that the actual Fable compiler. And the next thing, I hope you can see this, but that's kind of the beauty of it. It goes from F# to Fable. It optimizes the Fable a bit, Fable AST, and then the Fable to Babel gets the Babel JSON notation that we need to give back to our calling client. So it's really it's functional programming at its best. It's compiling everything. It goes from one function to the other. We can see that it's hooking the Fable compiler. There will be two declarations. So these declarations were the thing we saw in the typed AST. Moving once, moving twice. We had two let statements, remember? Then it creates a Fable file, and off we are. So if you now look at our console window, we can see that, okay, the Fable CLI, while debugging, it gave us the exact same JSON, and we created JavaScript from it. So in actuality, that's sort of how it works. Sorry, I'm just going to keep it like this and slowly go over it. We saw that, okay, we compiled it ourselves, but it's not really practical, is it? It's like, yeah, I don't want to do that. I want to create my own node file each time. So I want shit to happen when you press save and then compile and everything. So that's why they're Fable clients. These kind of solve this problem for us. There's one called fable-splitter, and the other is more popular, the fable-loader, being used with Webpack. The splitter is actually fairly straightforward. It takes the individual F# files and then compiles them to JavaScript, just one-on-one. The scenarios you will only use this are like Node.js or unit test, or basically everything that you don't need the bundle itself. Where it's a bit of a simpler world, you don't need a bundle. For setting it up, you can use a configuration file, splitter config, and you can also just use the command line interface. You can just say, okay, let's split this. This is my input. There's my output, and that's kind of the end of it. So it's a simpler setup. I have two demos for this. One is going to be your Node.js MVC application, and the other is going to be Pika. Has anyone heard of Pika? Great. I'll get to that. A little bit of preview. It revolves about the idea that the browser does not need a bundle anymore. So we'll get to that. Going back to the example, I have a splitter MVC. I have a little demo. I'm using script files. Maybe just slowly mention what actually is going on here. I have this packet dependencies. I think most of you kind of know Packet. It's an alternative package manager for NuGet and other stuff. So the nice thing is that I have like this GitHub line here on my package config. You can download other files as well. And basically, when we are using scripts, we create a load script. There's a command in package that creates this. And suddenly, this gives you all the IntelliSense. And these are hard-coded paths, but then you sort of agree with your project that, OK, we're not going to commit this file, but everywhere in our own code base, we're linking to this file. It should exist. So the first time you check out a repository, you kind of do the packet load and then have everything set. We have here our JavaScript. We have Babel. We're going to use browser sync to host our web server. We're going to use a compiler and then a Fable client called Splitter. We're also using React as a view engine and Express to match some routes. So this is really going to be your standard MVC stuff. The cool thing here is that we can use fable-splitter, give it a file, say we're going to watch it. We want the debug flag. We want common JS modules because it needs to run in the node execution. Then we say the output should be bin, and once it all compiles, each time you should run this command, and that run command is just node bin application, which will start up our Express example. So let me just start this, and I'll show you the code real quick. So maybe, let's see the example first. Browser sync is watching the files. Fable is compiling. Not sure if I have the right ports. Yeah, there we go. So a simple example. We have a list of speakers here. And then if we click on one, we go to a detail page and etc. and we go back. So we have like two URLs that kind of work. If we go back to the code, it's it's fairly straightforward. Well, if you've ever done anything in Express, it's just Express. So we create sort of an app, and then we say these are our two get routes. Once we have a route, we have a callback, and we create our detail page, for example, based on the short name. This is just a function that returns a React element. That React element and a really little helper function for that. We are just going to use React DOM server. So this is all being server-side rendered. It gets rendered to a string, and we just send it back as the HTML. For our layout page, if you have more of an ASP.NET Core MVC kind of background, a layout page, it's all just a function. It's like the running F# joke. It's all just functions. And we sort of have our index page where we just map all our speakers. We create list elements, etc., etc. We have our detail page. We find our speaker. Maybe the speaker has a, maybe we found the speaker. I mean, you never trust the incoming parameter on the URL. And so this all just kind of works. And now I'm just going to try and change anything so we can quickly see why we wanted to use browser sync. If I do it like this, I go to the index page, should have an H1 here. Let's go with an H5. I save it. Fable picked it up, it compiles it, and browser sync noticed the JS file refreshed, so it reloads the browser. And the cool thing is, this is all happening server-side. So this is pretty neat. This is what, like, to me, a simple setup, and we we just got what we know. We have our node output. maybe the one thing to notice about the JavaScript that comes out of it. We have our exports, and we have our module, module.exports to get things public. And then we have imports as well at the top, so or requires. So we're using the existing Node ecosystem. So you don't always need a bundle, and especially server side. The next example is going to be Pika. Pika tries to say we don't need a bundle, and if we install things, we can just use them in the browser and use the modern ES6 import statements to get around. And what Pika does is we're installing React and React DOM. There are other versions because React doesn't ship a ES6 bundle, it ships something else. So we need special versions of React, but these are just like the latest React versions compiled to an ES6 format. And if you launch the Pika web, it just says, okay, everything I found, I'm going to put it in the web modules folder. And in the web modules folder, I'll just have my dependencies. And in my own code, I'm just going to compile every file one-on-one with the splitter in mind. So if I'm using fable.react, I just get all these files, and everything just happens with an import from. And at runtime, there will be network requests, and that's kind of what the web is moving forward to. So that's the ES6 kind of way. I hope at some point when IE finally dies, we can use stuff like this and don't need to worry about the bundling. But I do have a little bit of a different setup. I sort of created the script to tie it all together. I'm going to run this and explain it in the meantime. The first thing we do is we're going to use fable-splitter from an API point of view. So we're not calling it from the command line. We're just using the splitter function as is. And we're going to use browser sync also not from the command line, but on our own terms. We have our splitter options. And there's one little thing in here that's interesting, is that there's a Babel plugin called Pika. Pika Web Assets Babel plugin that will change everything where you use import whatever from React. It's going to say, no, import from web modules React. So it kind of links those two together. We have a function where we compile JavaScript, where we're just going to use the splitter. The splitter just needs our options, etc. We're going to watch the one file we have on ourselves. This is pretty standard stuff. If you've ever done anything with Node, you just watch the file, and it's straightforward. And then we have a couple of middlewares for our dev server, for the web server itself. That's going to be, is it a module request? And is it ES6 middleware? Because when you're, the browser sort of expects when you're calling for an import whatever, the file extension, you can drop it. So that's part of the spec. But then, we don't know what file we should return here, so that middleware sort of takes care of it. And it should have an additional header. If the header is not application.js in JavaScript, then it doesn't work either. Okay, so our browser sync started on localhost 3003. 3002. All right, there we have it. So this is a simple React application. We just have our Elmish counter kind of thing here. But the interesting is if we go and look at the network tab, when we go to the JS, we reload it. It's going to see a lot of things have a 200 OK, and that means we actually put the cache control header on those. So the browser doesn't need to ask the server again whether it should download the file, whether it's changed. For our development purposes, there are a lot of files we kind of know that will never change. You're not going to change React all of a sudden or everything that comes with Fable. The only thing that it really downloads is our app.js file. So it's really nice to have a page reload, have a modification. Browser sync picks it up, and it already has all the other files. So let me just quickly edit the code here. So you can see we'll have sort of a similar effect. Say h1 becomes h5. We save it. Fable-splitter compiled it. We are watching the file. It's all there. It reloads, and it's pretty fast because it only downloaded a couple of files. All the rest is just remained in the cache. So that's really good. But of course, there's a bit of a, why should I use this? Well, for deploying it's kind of cool. But if you have like a state here, what you can do in Webpack is then you can sort of preserve the state with Elmish. If you change this here and say increase will not do anything, we reload and we see the page, and yeah, everything is gone. So if you want to solve that problem, you sort of need to write it in your own code to preserve state. You're keeping with a page reload. So it's interesting, but it doesn't really feel that developer friendliness we've known and come to love from Webpack. So in that regard, it still lacks something. But it is interesting. With little effort, we were able to, just compile things with Fable and not have to worry about the entire Webpack kind of thing. All right, moving on. The next one on our list is sort of Webpack. We kind of all know it, so let's just dive into the demo. I have something of lazy and suspense. And that's how you can lazy load a certain piece of your Webpack bundle when you request it. And when your URL changes, for example, and you can request it later and not have it in your initial bundle that you load. The thing is, I sort of touched upon this in a webinar I gave for JetBrains a couple of weeks ago, and I said something about Fable scripts, why they are great, and they are still great. But I sort of lost my selling point there, and I want to retcon that. So we're going to have the exact same application, and then you'll see what the real difference is between a script and a project file. So we have a project here, which is just your really standard .NET stuff. You're using NuGet for this example. It's all there. We have a Webpack config. I'm sort of assuming everybody's seen this. Quick recap: you have the fable-loader that just checks your FS files, X or Prosh or nothing. And then, it gets picked up and it creates a bundle, and that's sort of how Webpack works. It's still a confusing thing, so let's not go deeper into it than we need. We sort of need this little bit, and we kind of know that the fable-loader in terms will talk to the fable daemon, just like the splitter did, just like our debug example did. So it all works the same way. What I was trying to show in that demo is if we run start and we have this kind of page routing, we have a single page application. You can do something like React lazy, and a lazy component you have to give it a promise, and that promise should return a React component. And if you have one of those lazy components, you can create them. So this is like a type definition, and then here we create an element. So this is very verbose, but it's just me discovering the API, not really thinking of it should be user-friendly, just trying to get it work as close to React as possible. Because React has rated the documentation and said, okay, I just want to use this in Fable, so let's stick to closely to what React does. And basically what happens in my app components, I'm using a hook for this. This is use route, a package I'm using. The route results might contain a page, so it returns an option. And then I have this suspend element, and a suspend can capture a React element that's not there yet. And if it's not there yet, it's going to show a fallback, which is a loading component in my case. And then the page is one of those dynamic guys. So if we go to the example, all right, you can see we have multiple pages, nothing very special happening, but from a developer tab point of view, you can see we have an initial bundle, we have to.bundle, we configured Webpack in a fashion that it will capture everything. And if we go to the About page, we sort of load the bundle for the About page. So that's a really interesting take if you're creating this big, large Elmish application, and you have certain parts that you can sort of split up. You really can save the initial payload of bundle downloading, and each page can be downloaded individually in this example. And I sort of thought that this was only possible with using scripts. So the original sample of this is using F# scripts. And we have this app.fx. We have pages like this. And what the only difference in the import dynamic is just that we download another type of file. And I thought that was kind of required to do. It otherwise doesn't work. Webpack doesn't know how to deal an individual FS file. And that's like sort of the case, but the thing I kind of want to teach you guys here is that if you have a Webpack bundle with a single app.fs file, so this is not doing anything special, but we're having our Webpack configuration, we're just going to compile this one file. That's not going to work out. We're trying to compile it, give Webpack some time. It's going to fail because it can't find the projects. And in the beginning we said, yeah, when we're debugging the compiler, you always need an F# project, you need to figure out the references, you need to get to the Fable project and then start the whole pipeline. And it fails here because a single file on itself is not enough to grasp everything. But if you're in an existing project and you load an additional single file with a dynamic import, it does kind of work. And not kind of, it just works because Fable already knows that it's linked to a project. So what I'm trying to tell here is that I sort of lost my my selling point here. My argument of using F# scripts, kind of stinks. And it's all about personal choice. I sort of have this idea that it would be great if we have like one script file compiles to one JavaScript file in one command that you just can go with Fable, do the thing, go to from F# to JS. But when using script files today, you still need packets. So where I was trying to solve the problem at you don't need a project file for your references, you now need a packet dependencies file. So in terms of sparing one little extra file, that doesn't really work out. So I was thinking maybe we can do it how Fake does it. Fake has this kind of packet syntax and uses packet core to download all of its dependencies. And the cool thing is when having a Fake script, you can just write it like that, and you don't need to have an additional file for your dependencies. This works, and it loads the IntelliSense script, and the Fake script can handle itself. So that's kind of cool. That's kind of what I was going for. Then there's also a language suggestion for the F# compiler to have a new sort of a syntax. If you do like #package, you can just give something that's on NuGet, and it will try and download the thing for you, and then get it into your interactive scripting capabilities. But it's ongoing. It's not going to be for tomorrow. It's a hard thing to solve, I imagine, and it's hard for the team to really nail it down. So yeah, that's a bit future music. We'll see how that goes. So that was kind of it. And scripts, scripts are all personal choice. But I wanted to wrap up with another thing that's been announced last year. Fable can compile itself. So Fable compiled itself, which leads us to an JavaScript file that can compile F# scripts to JavaScript. So it's a bit of an inception kind of situation. And that's actually how the REPL works. So if you go to fable.io/REPL, you can try things in the browser. That's like really cool, and that actually works purely client side. So I actually did this. I sat in an airplane and I compiled my scripts, and I was pretty amazed that such a thing is possible. So I would like to wrap up with a demo on the Fable compiler.js. Just to show you what's possible. If I have it JS only, I have a script file. It can be a proj file, I think. It doesn't really matter. And I'm trying to build an aquarium here. I have a bit of emojis here, and it's going to look silly, but you get the idea. We have a two-dimensional array, and we're going to fill it with some blocks. So nothing special. I avoided using any extra dependencies because, yeah, you're only using JavaScript, so there's no package manager involved yet. There's no way of figuring these things out yet. So if you look at the package JSON, we're going to do Fable and app.scripts. We're going to say we need it in CommonJS, and then we run it automatically. But yeah, this is my dream. Fable, one file, one output. So it might go that direction. It's not for me to say or to do, but we have this one dependency here, Fable compiler.js. The other ones have peer dependencies, and the Fable compiler.js just has Babel as a direct dependency. So it's a different approach, and both have pros and cons. But the nice thing here is it just kind of works. It brings in one dependency. This is your Fable, and let's do it. Now, to prove it really works on a JS-only kind of thing, I've created a little script that runs a Docker file. It's going to use Node 12, and we're going to start a replication from there. So if we go to the JS only, we're executing the run file. We're in a Node.js container. I've linked my my files to here. So this is I think it is Alpine, not really sure, but it doesn't really matter. We have our Node modules. We installed already everything. Let me just prove that. Yarn is already up to date. We can now say yarn start. It will use the Fable compiler.js version. It also, it works the exact same way. So the F# compiler itself was slightly modified, and then is being used in an Imperial.js fashion. And yeah, this doesn't really point out the aquarium thing I was going for. Let me just go to another terminal which understands emojis. This is like the new Microsoft terminal thing. And if I now go in, maybe let's just exit here just to be sure. If I now go run, no, first go to the right demo, sorry, go for the run. Yarn start, does the exact same thing. And voila, you see blue bits of pieces, you see little animals. Emojis are really, the best thing in my generation, I guess. Yeah, so it's really interesting the way we started from the whole JS, from the, it uses F# tooling, and then we sort of go beyond that with these kinds of examples. So it's really nice. And that's sort of what I wanted to wrap up with. Thank you all.